First question says simplify 125 times x to the power of 6 whole power 2 over 3. So whenever there's a power outside the bracket and inside the bracket, they get multiplied. And if there's like a coefficient with a variable, the power gets distributed to the coefficient as well. So it's going to be 125 to the power of 2 over 3 times x to the power of 6 whole power 2 over 3. Now, 125 is basically 5 cubed. So 5 cubed whole power 2 over 3 times x to the power of 6 whole power 2 over 3. So as I said, when there's a power outside the bracket and inside the bracket, you distribute it, and after that you multiply the powers. So 5 to the power of 3 times 2 over 3 is going to be 5 square. And this is going to be x to the power of 4. So that's going to be 25 times x to the power of 4. Next question says a bag contains 10 sweets. 5 sweets are red, 3 are yellow, 2 are green. 2 sweets are taken from the bag without replacement. Work out the probability that the 2 sweets are different colors. So instead of doing the different colors, let's find out the probability of the person grabbing same colors. So if the 2 red, that's going to be 5 over 10 times 4 over 9. Now, the reason why it's times 4 over 9 is because it says without replacement, which means there's one less sweet in the bag now. And since we're talking about taking 2 red, so 5 becomes 4 as well. So that's 20 over 90. Now, if 2 sweets are yellow, that's going to be 3 over 10 times 2 over 9. So that's 6 over 90. And if 2 are green, that's going to be 2 over 10 times 1 over 9. That's 2 over 90. So probability of same color would be 20 over 90 plus 6 over 90 plus 2 over 90. That's going to be 28 over 90. So probability of different color, we will subtract this from 1. So that's 1 minus 28 over 90, which is going to be 62 over 90. And that can be simplified to 31 over 45. The reason why we did 1 minus 28 over 90 is because there are two conditions for this. Either he's taking different colors or he's taking the same colors. So if you find the probability of the person taking the same colors for the sweets, then the remaining possibility is that he grabbing different colors. So the total probability of an entire event happening is 1. So from 1, if we subtract the probability of getting the same color, the remaining probability is the probability of getting different colors. Hence, that's why we did 1 minus 28 over 90. And that gives us 31 over 45, which is the probability of the 2 sweets being of different colors. Next question says W is directly proportional to C squared. So directly proportional to C squared. So W equals to K times C squared. When W is 16, C is 2. So when W is 16, C is 2. So let's find the value of K, which is the constant of proportionality. 16 equals to 4K and 4 equals to K, which means W equals to 4 times C squared. Find the value of C when W is 28C minus 49. So 28C minus 49 equals to 4C squared. So if we think everything on one side, we can see that we have a quadratic equation. So now we need to factorize this quadratic equation. We'll begin with multiplying the coefficient of C squared with a constant. So 4 times 49, and that's going to give us 196. Now we need to pick a we need to find factors of 196 and choose that factor and choose that sort of factors which when added or subtracted gives us 28. Now we know that 14 times 14 is also 196. And 14 plus 14 is 28. So we can replace the middle term, which is negative 28c, by negative 14c minus 14c. Everything else remains the same. Now we'll factor this quadratic equation by grouping. We create two groups. The first two terms make one group and the last two terms make another group. So if you look at the first two terms, we have 2c common. Inside the bracket, we'll have 2c minus 7. And the second group, we have negative 7 common. So we'll have 2c minus 7 inside the bracket again. So 2c minus 7 times 2c minus 7 equals to 0. So c equals to 7 over 2. That is your answer. Next question says that shown is a right angle triangle, find the value of x. So we have a right angle triangle. They haven't given us like specific values for the opposite, adjacent, and hypotenuse, but they've given us expressions. So we can easily apply Pythagoras and say that 5x plus 1 whole square, which is the hypotenuse, opposite, adjacent, equals to 2x plus 3 whole square plus 2x plus 4 whole square. So now expand the bracket. So this is going to be 25x squared plus 10x plus 1 equals to 4x squared plus 12x plus 9 plus 4x squared plus 16x plus 16. Let's collect everything on one side. So this would be 25 minus 25x squared plus 4x squared plus 4x squared minus 10x plus 12x plus 16x minus 1 plus 9 plus 16. Negative 17x squared plus 18x plus 24. So now we have another quadratic equation. We have to factorize this. I'm going to first make x squared positive. So that's going to be 17x squared minus 18x minus 24 equal to 0. This is the quadratic equation that we'll factorize. So to factorize this quadratic equation, I'm going to use the quadratic formula. It's going to be x equals to minus negative 18 plus minus square root of negative 18 square minus 4 times 17 times negative 24 over 2 times 17. The reason I'm using the quadratic formula is because firstly, the values are very big. And instead of us wasting time in finding the factors, it's easy to just go for the quadratic formula and get our answer in less time. So that's going to be 18 plus minus square root of 1956 over 34. 18 plus minus 44.2 divided by 34. So one value would be 18 plus 44.2 over 34. That would be 1.8. And the other would be 18 minus 44.2 over 34. That would be negative 0.8. So these are the two values of x. Since x cannot be negative, so we're going to go for 1.8. Next question says that shown is a rectangular base pyramid and the apex is directly over the center of the base. Calculate the angle between the face ABE and the base ABCD. So in this question, what we'll do is, first I'm going to find the length of AC. Why? Because it says that apex is directly over the center of the base. So if it's directly over the center of the base, this is one right angle triangle that we have. And this is another right angle triangle that we have. So if I have the length of AC, I can divide that by 2 So let's begin with that. AC squared equals to 5 squared plus 8 squared, which is going to be 25 plus 64. And AC is going to be the square root of 25 plus 64, which is basically 89. So square root of 89 is 9.43 centimeters. So now if we call this x, AX is going to be 9.43 divided by 2, which is 4.715. So this is 4.7 and this is also 4.7. CX is 4.715 and AX is also 4.715. Now 8 is the length of AD. AD and BC are the same because it's a rectangular base. So that means this length over here is going to be 4. We call this Y. YX is 4 centimeters. Now, what we're going to do is we're going to find the length of EX using the triangle ECX. So EX is basically going to be EC squared minus CX squared whole squared. So that's going to be 10 squared minus 4.715 squared. And that's going to give us 8.81 centimeters. So now since we have the length of EX and we have the length of YX, we can find the angle that the triangle ABE is making with the base. How? Because if we connect E and Y is a line that lies on the face ABE, and the angle that EY will make with the base is the same as the angle that the face ABE will make with the base. So for that, we're going to use tangent because we have the opposite and the adjacent. So tan of theta equals to 8.81 over 4. And the angle would be tan inverse of this fraction. And that's going to be 65.6 degrees. That is the angle between the face ABE and the base ABCD.